Alright, hello, welcome to a new video. Just woke up, but today's problem is search and insert position number 35. This is an easy problem, and as you can see, I already solved it, but that's okay. I don't have that much time to do like medium problems anymore, because usually for me, they take me like an hour or two to study, and mostly an hour or two, but I need to use that time for my internship and my other work. So yeah, so I guess we're just doing an easy problem. You know, they're easy. Even by looking at it, I kind of know the solution already. Um, yeah, so let's just go through this using my problem solving process. My problem solving process, I just like to read the problem, get the input and output. Then I like to go over an example to showcase that I do understand the problem before going into it. And then after that, I like to go over some approaches that I can do. Then once I find an optimal approach that I can do, and that is optimal, I just like to go ahead and plan it using some pseudocode. And after that, I like to implement the plan, review it by going through it, and then evaluate the complexities. So let's go ahead and do this thing. All right, so let me get up my VS Code. Okay, so given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. Okay, so let me just go over it again. All right, so we're given a sorted array of distinct integers. So given sorted array of ints, and then a target value. Target value int. Okay, and what are we supposed to output? Then we're going to return the index. So output return index of target. If not found, then return the index where it should be. Not found where it should be. Okay, and so to basically showcase that if I do understand it, let's go through an example. Let's say our input is equal to an array of sorted integers. So let's say like 1, 2, 3, 4, 5. Okay, and then let's go find like something. Let's have a target that's like 3. Okay, so output the index of 3 is currently at index 2, so that would be it. Let's go through another example. Maybe make it harder, I guess. Say we have the same array, but let's have a number that's outside the scope. So let's just say like 6. So output, as we can see that we don't see the number in this array of integers, but we're supposed to return where it should be. So if I was at this 5, right? Let's say I'm pretty sure our binary search would be at this 5, right? So that's index 4. And so we would be like, okay, so to the right of it should be index 5 because that's where it is in sorted order, correct? So yeah, that's pretty much it. Um, let's do another case though, just to showcase like I do actually understand it. So let's say instead we have a different array with like some stuff, I guess. Okay. So and then it'll be 4 that we're looking for, right? Let's go output. Okay, so there could be two cases, right? It could either be our middle pointer or our yeah, we could stop here or here. I don't know which one, but either way, we could be like, okay, so is this number is this number that we stopped at, is it less than or more than the target, right? If it's more than, then we're gonna be like, oh, oh yeah, then we're like, oh, um, okay, so if it's more than, we're gonna be like, oh, okay, we gotta look to the right of it, so we're just gonna do this index plus 1, and then if it's less, then we're gonna do like, um, index minus 1, basically. It's kind of how it's gonna be. I kind of already, oh, I forgot, I didn't put the value. My brain's still like, I'm still working on it this morning. Um, woke up like 30 minutes ago. All right. For this one, this would be 5, right? And then for this one, that would be like 4. No, 1, 2, 0, 1, 2, 3. So be 3. Right. It'd be the same result either or if our pointer is here or here, right? So I feel like I do understand this problem. I kind of know I have an idea of what I want to do, right? Let's go over some. So now that we've gone through some examples, go through some approaches. I'm gonna list all of them, even though I already know the optimal one. So we can just go through iterate through. We can do like a for loop in range, right? That'll be like O of n. Or we can do like a binary search, which is O log n. We can do binary search because the list is in sorted order. It'll be really easy. When you hear binary search, you should hear. I mean, when you hear sorted order, sorted in ascending order, you should think of binary search immediately. Or you could maybe like try to do binary search because sometimes binary search doesn't work. But in general, sorted is binary search. Yeah. So now that we know an approach that we're gonna do, let me drink some water. Alright, water has been drank. Okay, so let's go make a plan for this approach. So, okay, so first thing I want to do my whole program. Let's just assume that this is like an interview, right? Where I don't have LeetCode to do all my stuff and like that. Let's create like a driver. So, I want to get user input. That'll be easy. And then once I get user input, I'll have because user input, I'll have basically like a user array and then user target. Right, I'll have like something like that. And once I get user input, what I want to do is I want to do binary search. So I want to do binary search. I like to type out what I do because my brain's really foggy right now, and if I have it typed right in front of me instead of like thinking about it or like saying it verbally, I feel like I'll be more in lock in the problem solving process, right? So that's just me. But I know pseudocode, you just write like pseudocode, but Python's already pseudocode already. So I think words also help there for me personally. So in binary search, I want to what do I want to do in binary search? But yeah, also if I type it out and I look at it, I'm like, oh, like how do I do that? Like I typed in binary search, but how do I actually do it? What I want to do? So that kind of helps out too. So in binary search, I want to have a left, a right, and a middle. So let's just say my left is 0. Well, when you start binary search, left is always like the start, and then right is going to be like the length of the list. So nuns, I guess, and then middle is equal to 0 just to initialize it. I mean, just to assign a value to it. Okay, so binary search. Okay, so I need to do a while loop. So while left is less than equal to right, I want to recalculate middle. So middle is going to equal to left plus right divided by 2. And then I want to check. So if nums at middle is less than no is equal to target, then I want to return because we want to return the index, right? I return index at the target if it's found, and then else if nums at m is less than target. That means we need to move left to the right. +1. And then else, we need to move right to the left. Right, so we can cut down the search. Okay. So at this point, this will return correctly if there is a number in the list. So I mean if target is in the list of numbers. So this case it'll be like that. So we need to look for 3. 3 is conveniently in the middle when we do our first iteration of binary search. So return 2, which is the index of 3 where it's at in the nums list. What about an example 2 where again I said that what you call it? We're gonna be at 5, but we don't find it actually because it's not in the list. Because it's not in the list, so we have to look to the right of it. So we're gonna do like this. So outside the while loop, we can be like, okay, because outside the while loop, we're gonna have middle at the exact spot, right? They're equal to each other. So we're gonna be like, okay, so if num's at mid, right? So if num's at mid, so basically if num's at this value 5, right? How do we find 6? Oh yeah, it's right here. Well, we can look to the so if nums at m is more than target, then we can say that we can just return m plus 1. Because if we're out of this while loop, then that means we're at m, and m is at this is at the edge of the list, right? And so yeah, so we just can return m plus 1. But in the case that m is less than target, we can just return m minus 1, because in this case, right? Let's just say that m. No, actually, let's make a new example. Example 4, where our input is 1, 2, 3, 4, and our target is 0. Right. Um, I'm pretty sure our binary search will end here at this 1, so index is 0. And then, ooh, that's a good question. Well, that's actually a good question. Okay, so in this case, we don't do -1. We have to do m, because if it was in sorted order, then if this was here, then this 1 would be popped up, would be pushed once, right? So in this case, it'll be at the index of m instead of m minus 1, right? So let's return m, right? Alright, so now that we got that, I'm pretty sure it'll work, but let me just test it with this case. Right, so let's do it with this case where let's do it easily. So let's go review, right? So we have this array, we find find this array, we have this array, and our target's 3. We do binary search, so left plus right divided by 2, so that's 0 plus 4. Divided by 2 is 2. This is index 2. Target is equal to nums at mid is equal to target. So return 2. That's good. Okay, so let's do this example now. Left is equal to so left plus right divided by 2. So 0 plus 4 divided by 2. That's 2. And now we want to find 6. Okay, so we don't find it here, so we move our left to here. So index 3 plus index 4 divided by 2. So 5, 6, 7 divided by 2. That's what is that? Is that 3? 2, 4, 6. Yeah, it's 3. 0, 1, 2, 3. So right here, mill's at 4. So index 3. It's more than target's more than. So we're like, okay, so move left to the right. So we're at index 4. So 5 plus 5 divided by 2. That's 10. That's still 5. So we're at index 5. Wait, 5 plus 5. Wait, no. 1, 2, 3, 4. Okay, so we're at index 4. 4 plus 4, 8 divided by 2. That's 4. Okay, and so we don't find anything. So we move, so we basically go out of this while loop. We don't do anything more, but we still have mid, right? So mid's still 4, index 4. And so we're like, okay, so is that index value more than or less than target? So it's gonna say it's 5 is definitely less than. So we're like, okay, we're going to basically return m plus 1. So that works. And then for this case, it should be the same thing where our middle is at 1, right? And so it should return m because it goes out of this while loop with m. Then we go through this, but it's gonna be else. Then we're going to return m, right? So yeah, that's kind of how it should work. So pretty sure it does work. So let's go ahead and plan. First off, our plan is to get user input. So go ahead and make a driver, which is main. Gonna pass it for now. Then I'm gonna run main in the whole program. And then I'm gonna get user input. So user array is gonna equal to an empty list, but on that list we're gonna get the input, and then I'm gonna split it. And then for elements in the splitted input, let's go ahead and turn those into integers. Right, and then let's go ahead and get the target. So user target is gonna equal to integer input. And then I should also make a function to solve this problem. So get a insert position. We'll take in 2 arguments, which is a user array. Name it nums and target. I'm gonna pass it for now. Oh, I forgot to define the function. I'm gonna pass it for now, and then in the main function in the driver code, I know I'm gonna call get insert position, and then I'm gonna return the index that it's at. So I'm gonna print out its return value while I'm calling it. And then when I call it, I want to give it the arguments of user array and user target. And then from here, from here, go ahead and do my plan binary search. So we gotta initialize left and right pointers, and middle is equal to 0, and then right is equal to the length, and then middle is gonna be assigned to 0. And then let's go ahead and do a while loop. So while left is less than equal to right, we're still going to calculate middle. So middle is equal to left plus right divided by 2. And then we're going to check, so if the middle value is equal to target, then we're just going to return the index middle. And then I forgot that target is tar. Okay. But else if nums at m is more than target, then we need to basically, actually let's just go ahead with my plan. So it's less than target. That means we need to move left to the right. So left is equal to m plus 1, but in the other case that's not. We need to oh, my monitor broke. Okay, my left monitor broke, but my main monitor still up. Okay, then right is equal to middle minus 1. Okay, so in this case, if we don't get into this return statement right here in this while loop, then that means that it's not in. So basically, if tar in nums, so if it's not in nums, if tar not in nums, we go through this if statement. So if nums at m is more than tar, we're just gonna I have to go with my plan. So if it's less than tar, then we're going to return m plus 1, but else we're just gonna return m, because in this case, right, we said that if it was in sorted order, we can't just say -1 as an index. We have to say 0 or the current index that we're on with m, right? That should work. Yeah, I already reviewed it in the plan, so let's just go ahead and do this like this. Wait, actually, let me just go through it. Any syntax errors? Maybe parentheses. That's always a good thing to have. Okay, so I think it's good. So let's go ahead and run this. Oh, I'm stupid. I'm supposed to give it a yeah. So let's go ahead and give it some examples. So let's say we do 1, 3, 4 and with 0. Okay, index 0, that's correct. What about 1, 2, 3, 4, 5 and we give it 6. Oh, out of range. Okay, so if nums, okay, so if nums, let's target. Okay, so in this case we're out of range. Yeah, is that possible? We're out of actually range, really? Or were we out of range at? I know it's because of this, but I feel like it should still work. It should still work. Shouldn't it still work? But of course it's not. So how does it go out of range? Let's go do this line by line, okay? Okay, so we have this array 1, 2, 3, 4, 5. Okay. All right. So currently, left is equal to left and right are equal to whatever. So 0, 0, and oh, -1. There you go. Okay, cool. So it should work now. 1, 2, 3, 4, 5, and then 6. Cool. All right. Good thing I looked over that. I'm so glad I reviewed it instead of like keep on running it because I look really stupid. But anyways, so to review, I mean to evaluate because we already reviewed, right? Um, I'm pretty sure this will still work. So, but let me actually put in LeetCode just to make sure. Let's go. Listen to music right now, but you can't hear it. Okay, BTS. Yeah, I forgot to make this target. Okay, so it works with the test cases. Let's go ahead and run it with actual code. Boom, it works. Pretty cool. Yeah, so to evaluate this time complexity, we're going through a while loop. I mean, what doesn't really matter, but each time we iterate, we're cutting the problem in half using binary search. So that's O log n time complexity. And then for space, we're using constant variables. We're not using any lists or data structures to hold our results or something like that. Or solve the problem. So O1, so O log n space, I mean O log n time and O1 space.